Hi guys, welcome back to another video. Today I'm gonna show you how to use the limit comparison test to determine if a given series converges or diverges. So let's first start with the rule. So suppose an is greater than 0 and bn is greater than 0. That means an and bn with positive terms. For some n greater than n when capital N is an integer, and the limit of an over bn as n goes to infinity equals c. So part 1, if c is greater than 0, then the series an and bn both converge or both diverge. Part 2, if c equals 0 and the series bn converges, then the series en converges as well. Part 3, if c equals infinity and the series bn diverges, then the series an diverges as well. So let's go through a few examples here and see how we can use these rules to decide if the series converges or diverges. So let's start with the first example. So the first example here, we have a series from n equals 1 to positive infinity and 2n plus 1 over n squared plus 2n plus 1. So first, note that as n goes to infinity, these two functions, 2n plus 1 over n squared plus 2n plus 1 and 2n over n squared, which is going to be 2 over n. So these two functions behave the same way as n goes to infinity. So I'm gonna so if you are not sure which function is gonna be your bn, just a graph the given series or the given function like this, 2n. Graph this 2n plus 1 over n squared plus 2n and graph 2 over n and see how they behave as n goes to infinity. And you're going to see pretty much they have the same graph as n goes to infinity. So I'm going to let bn equals 1 over n. I can choose 2 over n, but 1 over n it's much simple. So now let's find the limit of an over bn as n goes to infinity. So limit as n goes to infinity of en, which is our given series, over bn, which what we choose. So it's going to be limit as n goes to infinity 2n plus 1 over n squared plus 2n plus 1 divided by 1 over n. And now let's simplify. So it's going to be limit as n goes to infinity, so 2n plus 1 over n squared plus 2n plus 1 times the reciprocal, which is just n, and that's leave us with the limit of 2n squared plus n, so multiplying 2n plus 1 by n, divide by n squared plus 2n plus 1 as n goes to infinity, and that's going to be the limit of 2n square over n square, which is just 2. Is 2. Now we're going to use the rule par A. C is greater than 1, greater than 0 I mean. So the limit, so since 2 is greater than 0, and we know 1 over n diverges, therefore our series diverges as well. So n equals 1, infinity 2n plus 1 divided by n squared plus 2n plus 1 diverges by part 1, and it says both diverges or both converges, part 1. So now let's look at the one more example. So the second example is the series from n equals 1 to positive infinity 5 to the power n over square root of n times 4 to the power n. So same thing, you have to choose the series that behaves the same way as this series as n goes to infinity. So if you graph the function of 5 to the n over square root of n times 4 to the n powered, and the function 1 over square root of n, you're gonna notice they behave the same way as n get very large. So I'm gonna let bn to equals 1 over square root of n. And now the same thing, find the limit as n goes to infinity of an over bn, which is limit as n goes to infinity 5 to the n divided by square root of n 4 to the n divided by 1 over square root of n, which gonna be limit as n goes to infinity 5 to the n divided by square root of n 4 to the n times the reciprocal of 1 over square root of n, which is just square root of n. So now I can cancel the square root of n, and square root of n will cancel each other. So I end up with limit as n goes to infinity of 5 over 4 the whole thing to n powered, and that will be positive infinity. So now, bn, it's 1 over square root of n, which is n to 1/2, and this is a p series. So it's a p series and we know it's diverges if p less than 1, so which is p series n p equals 1/2, so it's the power of n, which is less than 1, so Bn diverges. And since Bn diverges, then En, so I need to do the series here, so series, then the series of En, so what I mean by En is the same series in the example, so n equals 1 to infinity, 5 to the end, divide by square root of n, 4 to the end, diverges by part 3, because the limit is positive infinity. So now let's look at last example here to just get more practice and how to use this method. So the last question is the series n equals 2 to positive infinity, n minus 1, and n over n times 4 to the end. So same thing, so if you graph this function n minus 1 and n to the times 4, that should be 4, n times 4 to the end, and 1 over 4 to the end, they will behave the same way, so behave the same way as n goes to infinity. So I'm gonna let Bn equals 1 over 4 to the n. And now do the limit. So limit of An over Bn as n goes to infinity equals the limit of n minus 1 over n 4 to the end divided by 1 over 4 to the end, and n goes to infinity. So simplify, multiplying by the reciprocal, so n equals goes to infinity, n minus 1 over n times 4 to the end times the reciprocal of 1 over 4 to the end is 4 to the end, and now I can cancel the 4 to the end, and I end up with the limit as n goes to infinity of n minus 1 over n, which is the same thing as the limit of n over n, which is just 1. And 1 is greater than 0. So let's find out what's if Bn converges or diverges. So Bn it's 1 over 4 to the end, that's square, so to the nth power here. So this is a geometric series, So it's geometric series with r equals 1/4, and 1/4 is less than 1, so Bn converges. Then our series, which is n equals 2, from n equals 2 to positive infinity, n minus 1 over n times 4 to the n, converges as well. By power 1 again. I hope you find these 3 examples very helpful to understand how to use the limit comparison test. So I will pause here and continue next time. Thanks for watching.